Chapter 14 Artistic Elements. As science grew more sophisticated throughout its history, it also grew more expensive, and big money began to decide if, when, and how science got done. Of course, during the 18th and 19th centuries, very few people, mostly rich gentlemen, could afford a little workshop in which to do their science. It's no coincidence that people from the upper classes were usually the ones discovering new elements. No one else had the time or the money to sit around and argue about what some mysterious rocks were made of. These well-to-do gentlemen throughout Europe received educations heavy in the classics, Greek and Latin, and many element names, cerium, thorium, promethium, point to ancient myths. The really funny-looking names, too, such as praseodymium, element 59, molybdenum, element 42, and dysprosium, element 66, are mixtures of Latin and Greek. Dysprosium means little hidden one, since it's tricky to separate from its brother elements. Praseodymium means green twin for similar reasons. Its other half is neodymium, or new twin. The names of noble gases mostly mean stranger or inactive. All of this seems odd today. Scientists receiving more training in Latin and Greek than, well, in science, but for centuries science was less a profession than a hobby for amateurs. Science didn't rely much on mathematics back then, and it was easy for anyone to say they were a scientist. Any nobleman, even one without much scientific or math training, could bully his way into scientific discussions, qualified or not. One such nobleman was a famous German writer, Johann Wolfgang von Goethe, probably best known in America for writing the play Faust. Many people still rank him as the greatest, most accomplished German ever to live. Goethe's theories relied as much on poetry as on science, but he did make one lasting contribution to science generally and to the periodic table. Döbereiner's Triads. In 1801, as a minister of the state, Goethe had the responsibility of picking a scientist for an open position in the chemistry department at the University of Jena. After hearing recommendations from friends, Goethe had the foresight to select another Johann Wolfgang, J.W. Döbereiner. Döbereiner's greatest contribution to science was inspired by one of the rare elements, strontium. A couple of doctors discovered strontium in a hospital lab in 1970. They named it after the origin of the minerals they were studying, Strontian, a mining village in Scotland, and Döbereiner picked up his work 20 years later. Döbereiner's research focused on finding precise ways to weigh elements, and strontium was new and rare, a challenge. With Goethe's encouragement, he set out to study the characteristics of the new metal. As he refined his figures on strontium, though, he noticed something odd but very interesting. Its weight fell exactly between the weights of calcium and barium. Even more interesting, when he looked into the chemistry of strontium, it behaved like barium and calcium in chemical reactions. Strontium was somehow a blend of two elements, one lighter and one heavier. Excited, Döbereiner began to weigh more elements precisely, looking around for other sets of three that he called triads. Up popped chlorine, bromine, and iodine, sulfur, selenium, and tellurium, and others. In each case, the weight of the middle element fell halfway between its chemical cousins. Convinced this was not a coincidence, Döbereiner began to group these elements into what we today recognize as columns of the periodic table. Indeed, the chemists who constructed the first periodic tables 50 years later started with Döbereiner's pillars. Now, the reason 50 years passed between Döbereiner and Dmitri Mendeleev without a periodic table was that the triad work got out of hand. Instead of using strontium and its neighbors to search for a universal way to organize matter, chemists began seeing weird collections of three everywhere, and they lost focus. Nevertheless, thanks to Döbereiner, strontium was the first element correctly placed in a larger universal scheme of elements, and Döbereiner never would have figured all this out without first the faith and then the support of Goethe. So even if Goethe made a poor show of things in his own scientific work, his writing helped spread the idea that science was noble, and he nudged chemists toward the periodic table. He deserves at least an honorary position in the history of science, which in the end might have satisfied him. Twain's radium. Goethe wasn't the only great writer to influence the periodic table. American superstar author Mark Twain was another. Like Goethe, Twain was fascinated by scientific discovery. He wrote short stories about inventions, technology, space and time travel, and even, in his story Sold to Satan, the perils of the periodic table. The story, 2,000 words long, starts shortly after an economic crisis around 1904. The main character is sick of having no money, so he decides to sell his soul to the devil. What does that have to do with the periodic table? Well, in the story, Satan is made entirely of radium. 6 years before Twain's story, Marie Curie had astounded the scientific world with her tales of radioactive elements. It was genuine news, but Twain must have been pretty plugged into the scientific scene to incorporate all the cheeky details he did into Sold into Satan. Radium's radioactivity charges the air around it electrically, so Satan glows a luminescent green. Also, like a warm-blooded rock, radium is always hotter than its surroundings because its radioactivity heats it up. To avoid burning the people he comes across, radium-bodied Satan wears a protective coat of polonium, another new element discovered by Curie. Scientifically, this is rubbish. A transparent shell of polonium, thin as a gelatine film, could never contain the heat of a critical mass of radium. But we'll forgive Twain, since the polonium serves a larger dramatic purpose. It gives Satan a reason to threaten. If I should strip off my skin, the world would vanish away in a flash of flame and a puff of smoke, and the remnants of the extinguished moon would sift down through space a mere snow shower of gray ashes. But Twain could not let the devil win. The trapped radium heat is so intense that Satan soon admits, "I burn! I suffer within!" But, jokes aside, Twain was already trembling about the awesome power of nuclear energy in 1904. Had he lived 40 years more, he surely would have shaken his head, dispirited yet hardly surprised, to see people chasing after nuclear missiles instead of plentiful atomic energy. Twain's story deals with the bottom of the periodic table and some of the newer elements, but of all the tales of artists and elements, none seems sadder or harsher than poet Robert Lowell's adventures with one of the oldest elements, lithium, at the very top of the table. Lowell's Lithium. Robert Lowell was a typical mad artist whose genius stems from parts of the mind most people cannot access, much less use for their own artistic purposes. Unfortunately, Lowell couldn't control his madness outside the margins of his poems, and in real life he often seemed crazy. He once turned up sputtering on a friend's doorstep, convinced that he, Lowell, was the Virgin Mary. Another time, in Bloomington, Indiana, he convinced himself he could stop cars on the highway by spreading his arms wide like Jesus. In classes he taught, he wasted hours babbling and rewriting the poems of his students. At 19, he abandoned a fiancée and drove from Boston to the country house of a Tennessee poet who Lowell hoped would mentor him. He just assumed that the man would put him up. The poet graciously explained that there was no room at the inn, so to speak, and joked that Lowell would have to camp on the lawn if he wanted to stay. Lowell nodded and left. For Sears, he bought a tent, returned to the house, and erected it on the grass. People loved these stories, and during the 1950s and 60s, Lowell was the most famous poet in the United States, winning prizes and selling thousands of books. Everyone thought that Lowell's antics were just those of a crazy artist being a crazy artist, but in reality, Lowell had a chemical imbalance in his brain, one that made him a manic depressive. The public saw only the wild man, not his horrible moods that badly affected his whole life. Luckily, the real chemical mood stabilizer, lithium, came to the United States in 1967. A desperate Lowell, who'd just been placed in a psychiatric hospital, agreed to try the new medicine. Lithium has no normal role in the body. It's not an essential mineral like iron or magnesium, or even a trace element like chromium. In fact, pure lithium is a scarily reactive metal. It catches fire when dropped in water. Nor does lithium, which in its drug form is a salt, lithium carbonate, work the way we expect drugs to. Lithium won't cure a bad mood. It only prevents the next mood from starting. Lithium tweaks the many mood-altering chemicals in the brain, and its effects are complicated. Most interesting, lithium seems to reset the body's rhythm, or inner clock. In chemically balanced people, the conditions around them, especially the sun, determine their mood and when they are worn out for the day. They're on a 24-hour cycle. Manic depressive or bipolar people run on cycles independent of the sun, and run, and run. When they're feeling good, their brains flood them with happiness, and a lack of sunshine does not turn the happiness tap off. Such people barely need sleep, and their self-confidence swells. Eventually, those surges wear out the brain, and people crash. Severe manic depressives sometimes stay in bed for weeks at a time. Lithium helps to regulate the proteins that control the body's inner clock. It acts as anti-sunlight and resets the body's clock to a normal 24-hour cycle, preventing both the highs and the lows. Lowell responded immediately to lithium. His personal life grew steadier, and at one point he pronounced himself cured. From his new, stable perspective, he could see how his old life had been so damaging. For all the moving lines within his poems, nothing Lowell ever wrote was as touching as a simple note to his publisher, Robert Giroux, after doctors started him on lithium. "It's terrible, Bob," he said, "to think that all I've suffered and all the suffering I've caused might have arisen from a little lack of a little salt in my brain." Lowell felt that his life improved on lithium, but the effect of lithium on his writing was debatable. Many artists report feeling tranquilized on lithium, and his poetry undoubtedly changed after 1967. Instead of inventing lines from his wild mind, he began stealing lines from private letters which outraged the people whom he quoted. Such work won Lowell a Pulitzer Prize for writing in 1974, but compared with his younger work, it's barely read today and not thought of as his best poetry. For all that the periodic table inspired Goethe, Twain, and others, Lowell's lithium may have sustained his health but damaged his art and made a mad genius merely human.